Hello there, welcome back. Now, I've been just right until now, I've been working on just kind of improving the display. I noticed in the last video that the little points there were really not very visible. I can actually see them in this icon, but you couldn't really see them in the display. Now, hopefully, this is better. I've increased the size of the dots. Probably don't need so many now. Maybe 100 would be okay. Let's see now. It's pretty much a parameter. Oops. Hundred. Is that all? Call the function with x. Yeah, that's better. It still go? Yeah, it still goes. Oh, no, it's 200. 200 because I have 200 points. Adding those points. There's two separate ways it draws. One using a list of points, and one using this song. That should do it, I think. I just have 100 points. The range should be the same. Okay. Yeah, remember I was saying this looks upside down than the usual, but in fact it's not. What's upside down is what we're used to in terms of Cartesian graph is that the increasing y is in the upwards direction, whereas on a computer screen it's the opposite. So what I'd like to do actually is flip these, turn the y-axis upside down. And so wherever I see a point, well actually all that matters is where I plot it, isn't it? I see I turn this into a function call. Well, that and drawing the ticks and everything. Line to move to. So really, this one should be minus, right? Y plus origin minus something, and I'm only just using y pause, right? X should be okay. The same with this. And then when I plot something, I use this plot point. And it should be minus, for the actual screen position, it should be minus the y. Just put minus. How about this? Flip. Just change everything. Flip. Okay, so that, well, it's not a pony, it's a point. Is that all I need to do? These positions are in actual screen positions, but I want for the plotting to be inverted. Well, let's see. What I'd like to do is invent a kind of function interface so that I could just add to this graph here, add a function, and then it would just draw it. Okay, now this would be, this is flips the x and the y. That's not good. That should be okay as far as this point goes. Oh, let me just undo this. Why don't I plot the flipped point instead? And now, what else would I do? The ticks. Y pause, X pause, I didn't change. Oh, X prompt, whoops. So B should be minus. In my case, for skipping, should be sign equals 1, I think. Maybe not. I skip one that it doesn't fit. It's a hack. I'm sure I could do this in a cleaner way. But it doesn't really matter. This is just visual. Alright. Well, it certainly drew this axis correctly. The function didn't get drawn correctly. Draw the x-axis. Origin x plus number of ticks times 25. Was this a minus before? No, it was plus. X pause starts at origin, and if the sign is positive, I would add a certain amount and subtract every tick. And the number I'm printing out is num ticks minus tick, which is a positive number. The position would be x pause point origin 1. No, that's to be the same as what it always is. And this will become negative. If I want to, oh no, actually that's correct. The positions of the numbers was correct. It might work now for the ticks. This is actually the right screen coordinate. Okay, we're almost there. Now, my condition I didn't change, and the graph is not drawing correctly. Plot point. I put this as negative. What I'm doing is I'm drawing a pixel with the pen, the current pen, and then I'm inventing a mixture color and drawing the 8 pixels surrounding that point with a mixture color. Now, x goes minus 1, 0, and then 1. Y. Well, if I didn't draw that part, I see. It has to do with something else. I think it's nothing wrong with that. But the point itself is incorrect. Because I'm adding top left. Also, there are no ticks. And they're not, it's not upside down at all, is it? Oh, if we're not, yeah, not in motion. Oh, hang on, I'm using the wrong set here. That's these ones that are being drawn. Let's just try putting a minus here. I'll have to fix all this up, make it proper later. It's completely correct, and I'm just drawing it wrong. I shouldn't have to put a minus here. It didn't come out right anyway. Those are the correct points. And if I'm drawing it by points, I go through here. Oh, this one too. Add origin. Uh-oh, I made a mistake. Sorry about this. Well, at least you can see if you can you see those points? I should just upload a short, this up to here, this clip, and see if those pixels or those plots are visible. Okay, Getting there. Plot point. Set pixel V. Now this is in screen format, so it's completely wrong. I can't do it this way. It's got to be what it is. It's got to just do the correct thing, the normal thing it normally does. And not try to muck up. So let me undo all this. It's not something you can just hack in. So I've gone too far. Yeah. Okay. This is, I started mucking around with it. Yeah. I changed the number. Oh, the number changes. We'll leave that. What I gotta do somehow is invert the view. Because that's the way that everybody's learned it in school, and I think it's clearer, easier to understand when it's in a familiar format. Now, why is that off center? Huh? Oh, I see. Look at that. Didn't have that flicker before. What did I change to mess that up? Something. Let me see. I shouldn't be calling this every single time. How about this? Oh no, I do, but on a move I want to do. So stupid. Why am I getting moved? I shouldn't be getting mouse moved all the time. Hang on a sec. I think it has. Oh no, it's okay. I thought it had to do with the recorder, because now it's fine. So anyway, yeah, this is an upside down Cartesian coordinate system. I want to flip the axes, and then this would actually have a slope of 1, which the sine function does. Sine of x, just sine of x, without anything added in the angle part. Its slope is 1, and the slope here is in fact 1, except that everything's upside down. What I want to do is invent. Now it shouldn't matter in terms of the picture. We can do it. Start doing it. A kind of function interface. Something like we'll call it I don't know, I function. Think of a better name later. So some completely pure virtual thing, class or struct. We'll give it an ugly looking name so that you would never actually use one. Let's look at the interface. The most basic function, not a graph. Right? So a function works like this. Double, and it'll have some member f, which takes a double, and that's a query, so it's really const. Now, you could make it non-const. I'll put it const for now. My friend always used to ask if it makes sense for a pure virtual to be const. There's nothing. Well, there's nothing to modify anyway, as far as data. But somebody might use a pure virtual as an indicator or a callback, and might do something. When that function, when virtual functions get called. And so he thought that maybe it's best that there never be const. But that's okay, you can always unconst things. Now, so that's f of x, right? Essentially, there's nothing more to it, except you might want to add in perhaps like a range and domain type thing. For what values is it defined on? Now, those things aren't really pure virtual. Those could have defaults, like minus infinity and plus infinity for x and y, at least for the domain, right? The values that go in here, I could call this y. Maybe y is better. This is y of x. Now x could default to being any value. Do I want to add any more than that? Okay. Now, these sorts of I functions and I whatevers are things that you don't want people to ever be able to declare, right? So maybe it's better if I make this a class. So I can disallow. Well, this can't be declared anyway because something has to be. Something has to implement this. But what I mean is we want these things to come from the heap. So we would like a function, a static function that returns one of these things. Let's say that it also is a reference kind of thing. Is that not what I call it? Okay, now we could return a smart pointer, or just a pointer, I suppose. Doesn't matter. It's going to start out with a reference count. Anyway, leave it like this. Create create or something. Taking some kind of identifier to say what you want. Well, actually, it doesn't have to be here. It could be in the particular types of functions that we want. Let me think about this now. If this goes here, then the only thing that can delete one of these things is refs. Something like that, or a smurf. Is that right? How do I usually do it? It's ref pointer, isn't it? I don't highlight it because nobody's ever supposed to use it. Let's see, the actual delete occurs here in refs, not ref pointer. So the thing that needs to be a friend is refs. Smart. Oh, hang on a sec. I've done this before. Okay, this seems to be right. That's what I had before and various other things. And so therefore, access to this destructor, which has to be virtual, is only available to refs. Nobody else can delete one, and therefore nobody can declare one, and so we're all fine. We don't need to do anything more with this definition. The only way to create one of these things and have it be able to delete itself is to make this mark pointer. Which we will call on H. Handle to a function interface. And we can, if we have one of these things, then we can use it. So think of an example function like a straight line. Straight line. And the thing that we have to implement doesn't even have to be public, but we can make it public. Right? We could imagine that we perhaps we have a slope. Right, and the two things we need for a straight line are a slope and one point, exactly 1 point on the line, or like they call the y-intercept or x-intercept. Now it depends. Not all straight lines intersect the both axes. Horizontal line doesn't intersect the x-axis unless it is the x-axis. But let's pretend that we don't have no horizontal lines and no vertical lines. So we could say M, the y-intercept. Yeah, that's the value we get when x is equal to 0, right? So the return value is, it's slope mx plus y-intercept, right? So there's an example of a thing that implements the straight line interface. Now, can someone declare one of these? No, right? If they declare this, it won't be able to delete it. So let me just standardize. Just want to verify everything's fine. Pragma 1. No, we just have to verify. Go somewhere safe. Here. Now, can I declare one? The answer better be false. Okay, because the destructor inaccessible, right? The only way to make that destructor accessible is through creating a smart pointer to a straight line. So can I do this? This should be okay. The smart pointer can delete it. Destructor cannot be because base destructor inaccessible. Do I have to make this a friend of that? Shouldn't have to. Maybe this should be smart pointer. Can't be. Let's get this wrong. I shouldn't have to do any friend stuff with these other derived things. Destructor inaccessible. No, that's not right. how do I normally? How do I normally do these things? How did I do it with that serial thing? Oh, protected strip, I see. I think this should still be refs. No, but then I could declare one of these. Right? I want to disallow this. It's got to come from the heap. We call it straight line. But now it's going to be fine because it has access to that destructor. Something I've done wrong. Hang on. Okay, well, I don't remember. But anyway, this is fine. This is going to has to be protected, and what you do is just make keep your constructors private, and just make a bunch of these create functions. I could make another one. Let's say that takes the two things that we need: a slope and make a constructor for that. You don't really need to. You can make functions to set those things. Set slope. Set intercept. Doesn't matter, does it? Okay. Oh well, constructor. Just like this. Double. Like this. Percept. You get the idea. Okay. And here we have a function. It implements the function interface, and we can make one like that if we want. And we might have a list of these function interface things that support y of x. Let's say the slope first. This would be a good slope, 1.636. And y-intercept x equals minus 20. Right? That should compile. Now I could pass one or more of these functions, just like I pass points to our graph object, And when it's asked to draw itself, it can draw all of the functions as well as points or other objects that it has. That's what I'm thinking. Now with that, I can just let's go through a very brief review of some very basic linear algebra topics to do with lines and coordinate systems and graphs and slopes and all that sort of thing. But anyway, I want to see how those new dots look like, and if they don't look good, I'll try something else. Okay, see you.